Hi, so welcome again. Now, from the previous lectures, we have some idea about controlling the motors and the direction of a robot. We can move the robot forward, backward, left, right, and all. The next step, we want to do some decision making based on some sensor data. So, the sensors generally provides electrical signals to the Arduino board, and those signals are processed and then we take some decisions. So the first sensor which we are going to use is a photoresistor which we have picked from the library. Here is photoresistor, or you can search it here. So this photoresistor is going to change the value of resistance if I change the light intensity on the surface. So let us check it, that what is the range. So how do we note down, how do we measure that? We take a multimeter, and once we take the multimeter, in the multimeter I have different modes. I can measure current, voltage and resistance. So I need to change the mode to resistance, and you can connect any terminal to multimeter and photoresistor. So the connections are done and we start the simulation, and we can see that it's showing 180 kilo ohm. How do I change the intensity of light on this photoresistor? So click on this, and my multimeter is coming in the path. So stop the simulation, move the multimeter little away and start the simulation again. And now you can see there is a bar which shows darkness and brightness. If you move this bar, the value of resistance decreases as you move towards more and more light. So this is giving you a resistance of around 500 ohm at the brightest level of light intensity, and in complete darkness it will give you around 180 kilo ohm. Somewhere in the center it is around 1 kilo ohm. So this is a good information. Next, what we want to do, we want to measure the voltages which can come to an Arduino board from this photoresistor, but this is not generating any voltage signal. So what should we do then? Then we take a potential divider network. That means I take another resistance whose value is around the center value of this photoresistor. I join them, and if I join 5 volt or any positive voltage here and ground here, then at the center point I will get a voltage which will be divided by these two resistances. And when I'm going to change one of these resistances, this value of voltage is going to change. So we can very easily generate different voltage levels by changing the light intensity on the surface of this photoresistor. I can attach a battery here to test it, but let us directly take an Arduino board, and we will use the Arduino board power to make the potential divider. So I take ground, and I can connect ground here. I can connect ground on the other side as well, and then I take 5 volt and I connect it on the other terminal, and we label it red. So now these two are connected. At the center I want to measure the voltage, so I have connected it to the positive of my multimeter. Make sure that I click on multimeter and change the mode to voltage, and the negative terminal of my multimeter will go to the ground. All these connections are done. We are ready. So we start the simulation. So we can see this is complete darkness, and in this complete darkness the positive voltage which is connected on this terminal, and we are basically measuring the voltage across my fixed resistance. The variable resistance value is 180 kilo ohm, and this is only 1 kilo ohm. That means very negligible voltage is appearing across this resistance. But as I change it and I bring it somewhere in the center, so you can see 5 volt is almost equally divided. 5 volt is equally divided across these two, and as I move more towards brightness, I'll get higher and higher voltage. So I'm able to generate different voltages from 27 millivolt to 3.3 volts. So that is another good step. Now, where do I feed this voltage on my board? So on my board, I have these analog pins. Any analog signal can be taken as input on these pins. So I take it, connect it, fine. So is it going to be a simple thing that if my input voltage is less than, let us say, 2.5 volt, do this, else do this? But Arduino is a digital device. It cannot read analog signals directly. We have to convert that analog value into a digital number. So Arduino have a 10-bit analog to digital converter inbuilt. What does that mean? That means any analog value between 0 to 5 volt will be converted into a 10-bit digital number. So if I talk about 10 bits, 2 raised to power 10 is 1024. Roughly speaking, 1000. That means any voltage between 0 to 5 will be given a code between 0 to 1000, or 1023 to be precise. So 0 volt will be given the code 0, and 5 volt will be given the code 1023. That means something like 2.5 volt will have a code of 512 or 500 roughly. 2 volt will have a code of 400. 3.5 volt will have a code of 700, and so on. So these codes are what Arduino is going to understand, not 3.5. So now we are fine with that also. So what I want to do, that if there is darkness, I'm going to glow one LED. So take one LED, take one resistor, maybe 200 ohm, and I connect it to pin number 12 and ground. Okay, so I want to make a simple decision. If there is darkness, glow the LED. If there is sunlight, don't glow the LED. How do we do that? We need to write a code. So come to the coding part. I am speaking in English, that if this, do this, else do this. So there are control signals where I have this support: if, else if, repeat, or count. So I take this block and I say, okay, this is fine, but what should I insert here? Here my decision making mechanism need to be inserted. That means some mathematical operation. So I go to math. Is there any block which is comparing two numbers? Because I need to compare. So right, I got this. So I take it and insert. Okay. So if number 1 is less than, equal, not equal, greater than, equal to number 2, then do this, else do this. So what should be number 1? Number one is the analog pin A5 input. I need to read the input, right? So go to the input and see I have read analog pin. So take it and insert it. So if read analog pin A5 is less than, so I want to set the threshold maybe around 1.5 volt. So 1.5 volt means 300. Then output, go to the output, set pin number 12 high, else set pin number 12 as low. That is as easy as it can. So is it going to work? Let us see. Start the simulation. My voltage is 27 millivolt and LED is glowing. My voltage is less than 1.5 volt and it's glowing. That's good thing. So I change it. Voltage is increasing 1.23. It's still glowing. And as I go above 1.5, it stops. And anything above that. So the logic works fine. As I go below 1.5, LED start glowing. So darkness, the LED is glowing. Sunlight, the LED is off. So this is a very basic circuit where we learn how to integrate a sensor with Arduino board, how to make simple decision using if-else statement. So in scratch coding we have learned something. On the circuit point of view also we have learned something. In the next lecture we are going to use the same concept and make something bigger. Thank you.